My name is Ramesh HG, working as Assistant Professor of Mathematics, Government First Aid College, Tiptur. Today I am going to explain binary operation in algebraic structures. So, first of all, I am going to explain number systems. The set of all natural numbers. It is denoted by n. The set of all integers. It is denoted by z. Set of all rational numbers. It is denoted by q. Set of all real numbers, which is denoted by r. Set of all irrational numbers, which is denoted by q dash, and set of all complex numbers, it is denoted by c. Set of all natural numbers means it consisting of the numbers 1, 2, 3, 4 and so on. It is an infinite set. The set of all integers means it consisting of positive integers, that is 1, 2, 3 and so on. Negative integers, minus 1, minus 2, minus 3 and so on, including 0. This is called as set of all integers. It consisting of positive integers, negative integers as well as 0. Set of all rational numbers, it consisting of all integers and all fractions are rational numbers. So it consisting of all integers and all fractions. Set of all real numbers, it consisting of all rational numbers as well as irrational numbers. Set of all irrational numbers means the numbers which cannot be written in the form of p by q are called irrational numbers. The numbers which can be written in the form of p by q, where p and q are integers and q is not equal to 0, are called rational numbers. The numbers which cannot be expressed as in the form of p by q, where p and q are integers, q is not equal to 0, are called rational numbers. Real numbers is the union of rational and irrational numbers. It is the union of it is the union of q and q dash. Set of all complex numbers, the numbers of the form a plus ib, where a and b are real numbers, is called complex numbers, and it is denoted by the letter c. So come to the definition of binary operation. Let S be a non-empty set. That means it contains at least one element. At least one element. The operation star is called a binary operation on a set S. If for all a comma b belongs to S, then a star b belongs to S, or a star b is in S. This is a definition of binary operation. So S is a one non-empty set. It contains at least one element. Then if you take two elements from that set, if you apply binary operation star on those two elements, the resulting element, that is a star b, is also in S, then S is called closed with the binary operation star, or star is a binary operation on S. We call star as binary operation on S, or S is closed under the binary operation star. I will give an example. set of all integers. Set of all integers consisting of positive as well as negative integers including 0. You take two integers. 2 and 3. 2 and 3. You add those 2 plus 3 is equal to 5. We observe that the resulting element, that is 5, is also an integer. You take minus 3 minus 5, add them, minus 3 plus minus 5, minus 8, that is also an integer. The resulting element is also an integer. If you take 3 minus 3, add them, you got 0, that is also an integer. So in this way you can take any two elements from the set of integers and add them, then the resulting element is also an integer. Then we say addition is a binary operation on the set of integers, or integers is closed under addition. You can also say that integer, set of all integers, is closed under addition. If you take product of two elements in Z, if you multiply 10 into 3, 10 one number, one integer, 3 another integer. If you multiply 10 and 3, then we got 30. 30 is also an integer. If you take minus 3 and plus 3, you multiply minus 15, that is also an integer. If you take minus 5 and minus 10, that is plus 50, that is also an integer. If you take 0 and 10, 0 into 10 is equal to 0, that is also an integer. So in this way you can take two integers and multiply them, and the resulting number is also an integer. Then we say multiplication is also a binary operation on Z, or set of all integers is closed under multiplication. So in total, addition and multiplication are the two binary operations on Z. Okay. So a binary operation star on a set is a function from S cross S to S. S cross S means it is the Cartesian product of S and S. It is a Cartesian product. This is also a set S cross S, which consisting of ordered pairs A comma B, A comma B. Suppose I will talk star as addition and S as Z, then the binary operation addition on a set Z is a function from Z cross Z to Z. That means 2 plus 3 is mapped to 5. 10 plus 5 is mapped to 15. 1 plus 3 is mapped to 4, like that. Or 1 comma 2, the ordered pair 1 comma 2 is mapped to 3. 10 comma 2 is mapped to 12. 15 comma 1 is mapped to 16, like that. So the binary operations are usually denoted by plus, minus, multiplication, into and division symbol. So for example, addition is a binary operation on the set of natural numbers. I will already explained it. Addition, multiplication are the two binary operations on the set of natural numbers as well as set of integers. If you take subtraction is not a binary operation on the set of natural numbers. If you take subtraction, for example, natural numbers is consisting of the numbers 1, 2, 3 and so on. If you take 2 and 3, 2 minus 3 is equal to minus 1. So minus 1 is not a natural number, and hence subtraction is not a binary operation on the set of natural numbers. Addition, multiplication and subtraction are the binary operations on the set of integers. So here I already explained addition, multiplication, subtraction. You take 2 minus 3 is equal to minus 1 resulting element, that is also an integer. 10 minus 5 is equal to 5, that is also an integer. 0 minus 10 is equal to minus 10 is also an integer. So subtraction is also a binary operation on the set of integers. Division is not a binary operation on natural numbers and integers. If you take division, so 2 divided by 3 is not a integer and not a natural number, and therefore division is not a binary operation on the set of natural numbers as well as integers. Similarly, addition, multiplication, subtraction are the binary operations on the set of real numbers as well as in rational numbers. There are also binary operations on the set of rational numbers as well as real numbers. But division is not a binary operation on the set of rational numbers as well as real numbers. Addition, multiplication and subtraction are binary operations on the set of rational numbers, but division is not a binary operation on rational numbers. Let A star B is equal to, you consider another binary operation. A star B is equal to maximum of AB is a binary operation on n, z and r. N means it is natural numbers, z means integers, r means real numbers. So if you take set of all natural numbers, 2 star 3, 2 star 3, that is equal to 3. So 3 is a natural number. 5 star 1, it's equal to 5 because maximum of 5 and 1 is 5. 10 star 20, it is 20. Maximum of 10 and 20 is 20. That is also a natural number. That is also a integer. It is also a real number. So A star B is equal to maximum of A comma B is a binary operation on set of all natural numbers, set of all integers, set of all real numbers. Another binary operation is A star B is equal to A to the power of B. It is a binary operation on n, z and r. Suppose 2 star 3 is equal to 2 cube. 2 cube is 8. That is also a natural number as well as integer as well as real number. 10 star 2, 10 square 100. That is also a natural number, integer as well as real number. So A star B is equal to A to the power of B is a binary operation on set of all natural numbers, set of all integers, set of all rational numbers, set of all real numbers. Let star be a binary operation on the set S. There are number of interesting properties of binary operations on S. So if star is a binary operation on S, we can find a number of interesting properties of binary operations on the set S. For example, addition. Addition is a binary operation on Z. Addition is a binary operation on Z. Okay, that means set of all integers. Set of all integers. So one can observe that if you take two numbers, 2 plus 3 is equal to 5, which is same as 3 plus 2. 2 plus 3 is same as 3 plus 2. So this is one of the property of binary operation addition. And one can observe that 2 into 3 is same as 3 into 2. It is one of the property. The property we call it as commutative property. So Z satisfies commutative law under addition. Z satisfies commutative law under multiplication. Similarly, N, set of all natural numbers, satisfies commutative law under addition, commutative law under multiplication. So if star is commutative, A star B is equal to B star A. A star B is equal to B star A. So addition is commutative on set of all natural numbers, set of all integers, set of all rational numbers, set of all real numbers, set of all complex numbers. If star is associative, is another property of binary operation. If star is associative, then A star B star C is equal to A star B star C. First we have to apply B star C and then to A, and if you apply A star B then to C, both are equal. This property we call it as associative property. So all the number systems, that is natural numbers, integers, real numbers, rational numbers, they all satisfy associative properties under addition as well as multiplication. Addition and multiplication are commutative and associative in N, Z and R. That is, A plus B is equal to B plus A plus B plus C is equal to A plus B plus C, and if we come to multiplication, A into B is equal to B into A, and associative is yes, A into B into C is equal to A into B into C. If A star B is equal to A divided by B, is not commutative and not at all associative. For example, 2 star 3. 2 star 3 is 2 by 3. 3 star 2 is 3 by 2. They are different. 2 by 3 is different from 3 by 2. 10 star 5 is equal to 10 by 5. 5 star 10 is 5 by 10. They are all different. So this is not commutative as well as not associative in N, Z and R. If A star B is equal to A, is not commutative but associative in Z, N and R. A star B is equal to A. For example, 3 star 5 is equal to 3. 5 star 3 is equal to 5. So they are not equal. So it is not commutative. But this is associative in Z, N and R. In set of integers, you take set of integers. It consisting of positive integers, negative integers and 0. If you add any number to 0 or any integer to 0, 0 plus A is equal to a plus 0. We got a. So 0 plus 10 is equal to 10 plus 0 is equal to 10. 0 plus 5 is equal to 5 plus 0 is equal to 5. So 0 is a peculiar element. You add anything to 0, you got the same thing. Here 0 is called identity element of Z. So one name is identity element of Z. 0 is called identity element of Z under the binary operation addition. Under the binary operation addition. One can observe that a peculiar element 1. 1 into a, if you multiply any number by 1, we get the number itself. 1 into 10 is 10, 1 into 20 is 20, 1 into 0 is 0, 1 into 5 is 5, like that. 1 into half is equal to half, 1 into 3 by 2 is equal to 3 by 2. Here 1 is called identity element of Z under multiplication. So in total 0 is called identity element of Z, Q, R under addition. 1 is called identity element of Z, Q and R under multiplication. Let star be a binary operation on set S. If x star y is equal to y star x is equal to E, we denote identity element as E, then y is called inverse of x. Y is called inverse of x. For example, if under addition 3 plus minus 3 is equal to 0, 5 plus minus 5 is equal to 0, 10 plus minus 5 minus 10 is equal to 0. So minus 5 is called inverse of 5, minus 10 is called inverse of 10, minus 20 is called inverse of 20 under addition. If take 5 into 1 by 5, 10 into 1 by 10, 20 into 1 by 20, 2 by 3 into 3 by 2 is equal to 1. So here 1 by 10 is called inverse of 10, 1 by 20 is called inverse of 20, 3 by 2 is inverse of 2 by 3 under addition under multiplication. Minus 2 is called inverse of 2 in Z under addition. Minus 10 is called inverse of 10 in Z under addition. 2 by 3 is called multiplicative inverse of 3 by 2 in Q and in R. 5 by 3 is called multiplicative inverse of 3 by 5 in Q and R. So in this way we can observe that binary operation is one of the most important operation in algebraic structures. Thank you.